Hi everyone. So this week's lab is preparation of solutions, and we are going to do a lot of calculations on concentrations that will be given in various units, and this will be helpful in determining the right amounts of solute and solvent to be used in preparing solutions of exact concentrations. So most of the times you will walk into labs and you find out that the solutions are already prepared for you, but then we have to think about um, like what was the accurate weight of the solute, and then that was added, and the appropriate amount of the solvent that was added to make this solution. And there are moments that we need to make also correct dilution of the stock solution that has been provided. So in your report sheet, you will be expected to calculate the amounts of materials that are needed to make solutions with specified concentrations. And in this, we are going to look at the various units of concentrations that are commonly used in the chemistry. So molarity is an important one. We also have molality, we have parts per million, percent composition by mass, and mole fraction. So with all of these units, I'm going to walk you through the definition of each unit and a calculation, an example calculation of how to put together the solvents and the solutes to make the solution of the appropriate concentration. So let's begin with molarity. So the definition of molarity is the number of moles of solute per volume of solution in liters. So you notice that the units of your solution should be in liters. And to do this, for example, we have been given sucrose and we need to make 100 milliliters solution, that is 0.2468 molar concentrated. And so to do this, I'm going to use the whiteboard to do the calculation. And so again, our target concentration is 0.2468 molar. And so as we said, usually what I would do whenever I have a question like this is to identify the numbers that I have been given or the values, and then look for what has not been given to me and try to find a formula that can connect what I have with what I don't have to help me find what I do not have. So here, for example, we have the molarity, which is 0.2468, and this should be moles of my solute, and I'm going to divide it by the liter of my solution, right? Like the volume of my solution, right? So in this case, I do not have the moles of my solute, that will be what I'm looking for. And I have the volume of the solution, which should be 100 ml. But remember that when you're doing calculations dealing with molarity, you want your volume to be in liters. So if we have 100 ml, then that is going to be 0.1 liter of solution. And that will be multiplied by the molarity value that I have. And my answer will be 0.1 0.02468. Okay, so that is the moles of my sucrose. But it says how much sucrose would be necessary to make this solution. Just remember there's a connection between the number of moles, the molecular weight, and the mass. So to arrive at the mass of sucrose, I would have to multiply the moles by the molecular weight of sucrose. So basically it will be 0.0468 moles, and I will multiply this by the molecular weight of sucrose, which is 342.3 grams per mole. And as you can see here, the mole will cancel out the most, and I will remain with whatever value that I have will be in grams. And so if you do this calculation, then you will end up with 8.447964 grams. And in the correct number of significant figures, I'll just keep the the 8.448 grams. I hope that's clear. Awesome. So this is just the steps of how to calculate your molarity given the beginning concentration, and then determining the moles of your solute given the volume of your solution. Okay? And then next we will go to the unit of molality. Molality is defined as the moles of solute by the mass of solvent in kilograms. Okay, so again, given this example, how would you prepare 0.210 molar solution using 89.124 grams of water? Okay, again, we've been given the molality and we have the mass of solvent, which is our water here. So what we need to do is first convert the volume, the units of volume of water into kilograms. I mean, not volume, but the mass of water into kilograms. And that would be 0.089 kilograms. Again, I am going to use the whiteboard to do this calculation and use text. Okay. So I have 0.210 molar, and so that will be moles of solute divided by mass of solvent in kgs. Sorry. Again, 0.210 molar should be equals to moles divided by the volume of solvent, which will be 0.089 9.24 kilograms. Okay, so that means my moles will be what? 0.0187. And again, to arrive at the mass, I'll have to say mass is moles multiplied by molecular weight. And again, we are using sucrose, so we have our moles here will be 0.0187. We multiply by 342.3, and that should give us 6.41 grams. I hope you guys were able to follow the steps. All right, so we will go back to the next unit of measurement, which is parts per million. And as you can see here, the definition of parts per million is milligram of solute divided by the kilogram of solution. So the other one, the molality, was just taking into account the mass of the solvent. But here we are talking about the mass of solution. So when you mix your solute and solvent, the total resulting amount is your kilogram of solution. So we need to include that. So again, we have an example here. How would you prepare a solution that is 101 parts per million in sucrose? The final solution should be 88.8 grams. So again, we look at the variables that we have been given. So we have 88.8 grams as our final solution, mass of the solution, and we just have to convert that to kilograms by dividing by 1,000. And then we also have 111 parts per million. Okay, so in this case, again, I will share or use the whiteboard, and I will do another. Actually, let me just use my draw. Okay, and use the text. So here we have also been given our value, which is 111 parts per million, which should be equal to milligram of our solute divided by kilogram of solution. And in that case, we have 88.8 grams. That would be 0.0888 kilogram of solution. And this number would be mass of sucrose, which is equal to multiplying 0.0888 kilograms by 111, and that should be 9.86 milligrams. And so when you are asked a question, how would you prepare a solution? Usually, once you have the correct weight of your solute, then you also need to determine the correct volume or the correct mass of your solvent and mix them together. So in this case, we need a total mass of solution to be 0.088 kilogram. And that means the mass of our solvent and the mass of our solute are in this amount. So we have 9.86 milligram of sucrose here. Then how much water do we need so that we can have the correct concentration of the solution that we are targeting here? So the mass of the water will basically just be 8.8 grams, and we will subtract the 9.86 milligrams, which would be like what, minus 0.00986 grams. And that's a very small number, which will leave us with still about 88.8 grams of water. All right, so let's go to our next unit of concentration, and this will be the percentage, weight percent is what they call it. And the definition of that is just the mass of your solute divided by the mass of solution times 100%. I would need you guys to pay attention to whenever we have mass of solute divided by mass of solvent or volume of solvent versus mass of solution or volume of solution. Just be watchful about those so that you don't get confused. Okay, but here again we have another example that how would you prepare 234.5 grams of a solution that is 1.23% sucrose. So again, you have been given the percent weight or the weight percent as 1.23, and then you're expected to prepare 234.5 grams of a solution. So what we are missing in this formula is the mass of our solute. And if we want to find the mass of our solute, we'll have to multiply the weight percent times the mass of solution. So that will be 1.23%, and then multiply this by 234.5. So notice that this one does not specify if your mass of solution should be in kilograms or in grams or whatever. But for the sake of having uniform units, then you need to have a mass of your solute to be the same as the mass of the solution so that they can cancel out. So in this case, we can just keep it as grams, and then we will find the mass of our solute in grams at the same time. So if you multiply these two numbers, then you are going to find the mass of your sucrose to be 2.88435 grams, which is basically in the correct amount of significant figures, 2.88 grams. Okay. All right. Our next unit of measurement is the mole fraction, and this is defined as the moles of solute of a certain component divided by the total number of moles in the system. So if, for example, I have water and sucrose, they all of them will have different number of moles, but then for the total moles of solution, then I'm going to add the two components together. So this one you have to find the moles of solute. So we have sucrose here. We have been given the mass of sucrose, and to find the moles of sucrose, we have to say mass divided by the molecular mass. So that would be 91 divided by 342.3 grams per mole, and that will give us 0.266 moles. Again, we will go ahead and find the moles of water by using the molecular weight of water, which is 18 grams per mole. And we have been given here the mass of water to be 124.6 grams. So the moles of water would be 6.922 moles. So the mole fraction of this solution would then be, with respect to the to the sucrose, we'll have the moles of sucrose as 0.266 divided by the total moles in the system, which is 0.266 plus 6.922, and that should give us the number 0.0370. All right. And lastly, whenever we dilute the stock solution, then there's the concept, uh, there's this formula that shows us that the initial concentration of your solute multiplied by the volume of the stock solution, will be equal to the final concentration of your solution multiplied by the final volume of your solution. So for example, here you're told that 2.67 milliliters of 0.0223 molar calcium, this is copper 2 sulfate solution, is diluted to 25 milliliters. So our initial volume here is 2.67. Our initial concentration is 0.0223. So if you multiply these two numbers, we should be able to get the same value as multiplying the final volume times the final concentration. And so when you put these numbers together, you are going to find out that you're missing the final concentration, and then you have to take this value 0.023 times 2.67 divided by 25 ml, and that should give you the final concentration as 0.00238 molar. Okay, so once your solutions have been prepared, then it needs to have a label of the name of the chemical, the date of preparation, and the concentration with the appropriate units as we have been calculating or going through in the previous slides. Then it needs to have a preparer's name and also the potential hazards. So in your report sheets, you will be required to show calculations for the various target concentrations that will be provided to you. This is uploaded on Top Hat. And if you have any questions, please reach out to your instructors for clarifications and help in doing these calculations.